Good morning, Blake. How are we doing? I think we got everything good to go. We need to wake up Mubot. What are you working on? I think we have one question already from a student. I need to go grab that. A little bit of music here. Gotta keep moving my music thing over. Let's see right here. Got my grocery order in for tonight. Looks like it's still stuff in my cart. Order placed. Good. Grocery tonight is always a good thing. Mubot has woken up. Need to sign into my Pearson. Got my coffee. Coffee. How's your morning going, Blake? Did you order a... Well, the test went pretty well, I think. Like, it was a tough test. But number one thing to know is I will definitely give hints for what's on the test. I can't tell you literally what's on the test. Sorry, I can't do that. But was there the written 12 points that I said? And then there's a lot of little things I hint at where I basically try to say some test questions. And because usually on the day of, I'm looking over the test. And let me grab the question the student wanted while we're doing this. So my goal is to drop hints. And if you're writing down notes and taking things down, okay, they must be doing chapter 14, maybe homework. Did they say quiz or homework? Okay, it's either quiz or homework. Oop, here we go. I did make a dedicated note sheets with all the... Yeah, and how many did you... I'd be interested to know how many of them were on there. I hope quite a few were on there. Okay. We've got the housing market, but then I don't remember a ton of the moments on the test. Oh, no. Well, it's definitely just reviewing and trying to get the concepts down. It takes a while. Are they available? Are which things available to look at? Which things available to look at? The test should be up, right? Are grades not done up? Post grades? No, grades are posted, right? You can see, let me double check. Exam 2 grades. Exam 2 grades are posted. You should be able to see what you got wrong. Let me see if you can see what you got wrong. Review tests. There we go. Okay. Oh, man. No wonder. Okay, let me change it so you can see the correct answers till Friday. Okay. There we go. You should now be able to see the correct answers. Some people, I swear, had already seen the answers, or so they should be available now. That should fix that. Grades up. I don't know if we could see the... Yeah, so you should be able to see it now. I've changed it. Changed the setting on it. 503 chapter Stats Will 1. 501 Stats Will 1 chapter 14 homework. The housing market. Let's go check it out. The housing market question. Here we go. Okay, this question is about confidence intervals for the mean. So, Blake, what's it going to boil down to immediately with this question? What do you notice up here at the top, which we're going to need? I would not start this question yet. I would immediately start looking at this, and what's it going to boil down to start with every one of these questions throughout the remainder of the last bit of the semester. I always say start by identifying your what. It's going to lead you down a path. It's going to help you solve questions. It's going to be that
notation, brother.
So you don't want to start reading their question and being like, oh, what are they asking? Don't even worry about it. Don't even read the question. Start doing the notation for this. It says the housing market has been slowly recovering since 2008 crisis. Welcome to the 2022s where houses cost $1 billion. Little bits. Realtors randomly select 31. So we got randomly. The sample showed an average loss of this with a standard deviation of this. So what is the notation right here, Blake? What is the notation? So we haven't done, we'll do this chapter today, but what is the notation on this? We should know some of it. What is some of the notation here? I can help you out. Can you get 2 out of 3? Can you get 3 out of 3? What is some of the notation? So it's the new chapter for today that we'll be doing in class. N, great job right there. Sample size is 31. Yep. N is 31. Here, wait, I'll give you a hint on the formula we might be using. Y bar plus or minus T star S over square root of N. Not the margin of error. That is the standard deviation. So what is that? The sample showed a standard deviation. The sample standard deviation. The sample showed that is S. So the sample, that is sample standard deviation, that is S. That makes the sample the, so we'll plug it into the formula right there. You're right. And it hasn't asked us to solve this yet, but it's probably going down this path. And then that means right here, this is Y bar. There we go. Y bar is the sample mean. So that is the sample showed an average loss of this and the standard deviation. And then the T star is based on the percent confidence level. So we need to know how confident they are. And they might tell us later on to use a certain confidence level. So that's going to be relative to a certain confidence, the T statistic, which is a lot like the Z statistic. So let's look at the questions they first ask right here. What assumptions must be checked? The way they describe this. Condition 1. What is condition 1, Blake? Condition 1 is what? So this one violates it. That's not what we're doing right here. Random. So we need random data, which is not dependent. Random data would not be dependent. It would be independent. So that's good. They're assumed to be independent and from a normal. Good. Check the independence assumption with the nearly normal condition using a histogram. No, you wouldn't check the independence with a histogram. Okay, that's wrong. That one's wrong. The data are assumed to be independent and from a normal population. Check the independence. No, I think they're going over here. Here we go. Let me look at this one. The data are assumed to be independent and have a sample size that is large enough to have a sampling distribution. No, they're talking about the sampling distribution here. So no, because we're talking about sampling distribution. That sounds like previous. Hey, Taylor, good to see you here. The data are assumed to be independent and from a normal population. Check the independence assumption with the randomization. Ooh, that sounds good right there. Check the normal population assumption with the nearly normal condition using a histogram. Yes, that sounds right. There we go. So this is the small, they're being very particular. Oh, and they even said 10 successes, 10 failures. Okay, so that makes this one instantly wrong. Why would we not use 10 successes, 10 failures right here? That if I had read that, if I had gotten to that last part, I would have said no. Why would you not use success failure condition here? Why would you be like, no, this is not success failure condition? You shouldn't be like, okay, no. A city ballot, who'll do one next? You got it, Taylor. Why would you not do success failure condition here? So why is success failure condition like a nope? Why would we not use success failure condition? Success failure condition is only for what right now? I mean, it'll always be that. If you saw this, you'd be like, nope, that's a huge thing. Also, this is not a sampling distribution. So that's when I thought right here, when I got to the sampling distribution, it's not that. It's categorical, correct. So is that another one right there, Taylor, the environmental Oceana group? So success failure is only for categorical. So when you see this right here, that's a no. Dependent would not be random. So that's a no right there. And then the last one is a no. To check the independence assumption with the nearly normal. No, the nearly normal is used to check. Random is used. We think it's random to check independence. And nearly normal is used with a histogram. So it's better when they put it up here. Check the independence assumption with the randomness. Check the normal population by using the nearly normal with a histogram. So that's the right way to do it right there. 99% confidence. So now we need to go and find our what, Blake? It said 99% confidence. Now we need to go and find our what? It said 99% confidence. We need to go and find our what? What do we need to go and find now? Now we can go and look up our what? What do we need to go and find, Blake, now that it said 99% confidence? Close, not the Z. This time it's the T. Mr. T is mean. So this one uses a T. Now you'll be like, wait a minute, this looks a lot. That's the wrong. It's just the screen right here. How much does this curve right here look like the normal? How close do these curves look? Here's the normal. Here's the T. Normal, T, normal, T, normal, T. How close do they look? Do they look virtually identical? Very similar. What if I told you the z-score for a 95% confidence interval? What is the z-score? Do you know off the top of your head? For a 95% confidence interval, what is the z-score? For a 95% confidence interval, what is the z-score for a 95% confidence interval? 1.96. Wait a minute, that's the t. But you notice there's this thing called degrees of freedom. Degrees of freedom are the degrees of freedom for the curve to be normal. We need to know the sample size minus 1. So if the sample size is 2, the curve looks like this. Now, does this look really normal? Does this look just like the normal curve to you now? So the T-curve has what are called degrees of freedom. That's what the DF stands for right there. And it controls the shape of the curve. Does this look normal now? Does it look normal right now? It does. It looks very much like this curve right here. It looks just like that curve. This curve right here, which is all flattened out, looks just, I mean, it's bell-shaped, I agree, but it doesn't, I'd say it looks very different, right? It's more spread out. It has larger well, it's still the same standard deviation units, but it has more spread to it. The curve is more spread out and might have maybe more kurtosis, advanced terms for peakedness, even though Wikipedia says it's not peakedness. But with this right here, you might be wondering, what are the degrees of freedom? So to get degrees of freedom for the one sample t, the complicated formula is what are the degrees of freedom for this, Blake? So can you tell me the degrees of freedom for this curve? What are the degrees of freedom for this t curve that we need to be looking at? So you have to calculate, too complex right there. No, you got this. What are the degrees of freedom for this t? Every t always has degrees of freedom. You have to know the degrees of freedom to then talk about it. So what are the degrees of freedom for this t? So what are the degrees of freedom? Degrees of freedom equals n minus 1. So what are the degrees of freedom? Well, no, so the percent confidence is 99% confident. Degrees of freedom are n minus 1 for one sample t. So what are the degrees of freedom here? So you have to plug in, not 2000, good guess right there. So that's the standard deviation. So you have to find n and solve for degrees of freedom. Degrees of freedom are going to be 30. So the degrees of freedom are 30. And the degrees of freedom control the shape of the t. So when I give it more freedom, it looks more normal. Do you see how it looks a lot different now? When you change the degrees of freedom, you change the shape of the t. Notice how it's turning out more to be normal. And then now, if I want to do 99% confidence, I could enter in this, because that's 1% outside, or I could enter 99% inside. So n is now, no, n won't be standard deviation. N won't be, which part are you wondering about? N is used right here to find degrees of freedom. Degrees of freedom for the one sample t are n minus 1, Taylor. Does that make sense? Degrees of freedom for the one sample t are n minus 1. The degrees of freedom controls the shape. The green highlighter. Oh my gosh, Taylor, 5,000 points. What have I done right here? Taylor, 5,000 points. Brian highlighted wrong. Thank you very much. Good call. So n is here. Thank you, Taylor. There we go. Yeah, I didn't even notice that. Good catch. No wonder. Thank you for pointing that out. Yeah, you're like, wait a minute. Yeah, I didn't even see that we highlighted wrong. But yeah, well, let's say Taylor mod. I agree. Thank you, Taylor. Make Taylor a mod right there, and really appreciate you catching that error in the highlighting. And that makes it easier to see that the n is being used right here, and the s right here is standard deviation, and we do n minus 1. Thank you, Taylor. Great catch right there. I didn't even see. I was like, wait a minute, the green, the yellow? Yeah, you're right. So with this, the degrees of freedom are 30, and the t statistic is 2.75. 2.75. So now we go back here to our problem, and we plug in our numbers. So we plug in 2.75, and then 2046 over square root 31, plus or minus. Everything here is the what, Blake and Taylor. Everything right there is the what. Everything I've circled is the what of this equation. It's the plus or minus. This is the critical value, which is also gives you the confidence level. This is the standard error of the sample mean. And everything right there is the what. Like everything I've highlighted right there is known as the what. Like all of this quantity, this is the estimate, which is the center of the interval. We estimate it to be that. And so everything after the plus or minus is the what. The estimate has the critical value, which is related to the percent confidence. And then what is the whole thing over here? Like this, everything over here is the what of the interval. Good to see you here, kid. It's the margin of error. Great job, Taylor, right there. It's the margin of error, the ME, the margin of error. So that's all the margin of error right there. That's the estimate, which is the center of the interval, and know how to break these down, know how to solve them, and understand what these are. Everything after the estimate is the margin of error, correct. So that is what we estimated it to be, and then we have the plus or minus margin of error. And so 2046, here we need to do 31 square root. 2046, divide by that, and then times 2.75. That is the margin of error. So there we go. That should be right. And so let's go back to here. And 99% confidence. So we can just take this number right here and go 9936 plus that 10 to the nearest whole number. 10.9. Is that right? To the nearest whole number. 10.947. Just perplexed. Oh, well, which one are you wondering about? And round to the nearest whole number. 8925. Okay, let's hope we did all of our rounding correctly. We did! I love it. I love it. I love it. There we go. Is that it? It's a good question. The way they did the conditions, I'm not the biggest fan of. I prefer to do the conditions like condition 1, random. Condition 2, less than 10% of the population is sampled, which I should mention that. Condition 3 is going to be the nearly normal, that the curve is nearly normal, such that the distribution of the mean will be nearly normal. So we have to have you can say large enough sample size, but we can check the histogram too. There's a lot of ways to check to make sure it's nearly normal. So they kind of get into that. You can use the goodness of fit test. They don't go into super detail, but it's a pretty good question. Like it does a pretty good job right there. Next one is a city's ballot includes. A city's ballot includes. A city's ballot. That was a great question. No ban. We're not going to ban that one, Blake. A city's ballot where is the city's ballot one? Taylor, what chapter is that on? A city's ballot. What chapter is that? The environmental. Wasn't there a quote, keep this question? There should be. Is that the same question? Same sort of question. Where is I don't see a city's ballot and the environmental Oceana. Are those on the quiz? Let me go look at the quiz on this chapter. New questions this semester. What? I try to make it a point usually to do every question multiple times. Good practice. Keep this question. Quote 285. Blake, you got a good memory. I like that. We're looking for a city ballot or the Oceana. No, Taylor, let us know which chapter those are over. I didn't see any city's ballot includes the environmental. Chapter 13? Oh yeah, here we go. Chapter 13 quiz or homework. Woo! A lot of quiz questions. What, please? Pew Research. Pew. Chapter 13. Morning consult. The environment, he found the environmental one. Okay. Is that the first one? No, the second one. Let's do it though. Okay. A lot of questions. 21. Statue 1, chapter 13 quiz. Here we go. Let's go check it out. Okay, so that's fine. Looking at the notes. The environmental Oceana analyzed, Group Oceana analyzed 12,115 samples of seafood purchased across the United States and genetically compared, sure, the pieces to standard gene fragments that can identify the species. 32.8% were mislabeled. So what's going to be the first step to solving this problem right here? What is going to be the first step to solving this problem? Anytime you get a problem like this, what's going to be your first step? The very first step we always do on solving any of these problems is going to be
notation, brother.
So how much notation here can you identify? How much notation can you identify? What can you tell me about this right here? There should be 3 things. It also says 95% keep Leo. Oh, like that right there. It said 95% confidence in the next step. So N right there, great job. We have N right here. Sample size. Yep. Anything else? Great job, kid. Right there. We got to throw some points. Keep going. See if you can get the next ones, because the next ones are the more difficult ones. They're asking if something is mislabeled. They're asking if something is mislabeled. That's a hint for what we're doing right here. Labeled. Do you see where I'm going with the type of question? So that won't be the T right there. So what is that? Like, tell me in words what that is. That is the what of the what. And this won't use T for this right here. There won't be any T. So what I would do is I would have a whole sheet, kind of close, Blake. Yes, yep. Or technically, well, they're actually they're interested in what's mislabeled. You might think being mislabeled is a failure, like that would be logical. So you're on the right track. It's not going to be used as Q hat though. It's going to be used as what? You're on the right track. So it's considered a success. So that's the answer to the question. It's P hat, exactly. So they're interested in the percent. So as soon as you know this, Blake, what do you solve next? We're just practicing. Yep. So that's the percent of successes right there. That's what they're interested in. So now what do you solve instantaneously for? Now you solve for Q hat, which is 1 minus P hat. And so we go right here and we do 1 minus. So we're going to get 6, 7, 2. Check my math. These should add up to 1 because they're complements. So if you get those, it's going to add up to 1 right there. You can do 1 minus to get the other. Great job, Blake. And so now we need to look at the formula we're going to use, which is P hat plus or minus Z star, which means relative to the confidence level, P hat times Q hat over N. You do get the formula sheet on the test. And if you look, we already have some of these values. We have P hat, we have Q hat, we have N, but now we need to go and find the T statistic, which the T statistic is going to be relative to 95% confidence. So Blake, what is the T statistic for 95% confidence, which the problem tells us to use? Excuse me, the Z. Very sorry, I said T because we were doing T a moment ago. This is 1.96 for 95% confidence. We would give that to you on the test. It would say use a Z score of 1.96. And so if you don't know the Z score for one of the ones you're doing, make sure to click the second button. The link's in the chat. Type 95% and then make sure it's on the between to see a confidence interval which shows the above and below the estimate. This isn't really the estimate right now, but the Z score is 1.96, goes up to there and down to there, and it's basically 2. A lot of times when I do it in my head, I use 2. Quick way to solve it. Well, it is also kind of negative because of this. So it does the negative and the positive for us. That's why we don't really put in negative, because it just does it for us. Good questions there, Blake. Let's throw you more points. It's plus or minus 1.96 technically, so it does the work of the plus or minus for us by having the plus or minus right there. And when we do 1.96, that's why on the app you see negative and positive 1.96, and both of those values are being used right there. Good questions, Blake. So that is why it does it. It does the plus or minus on the margin of error. 0.672 over, and then 1215. So everything, we like to reinforce our knowledge. Everything over here, Blake, is the what? Everything over there is the what. We just say it every time we see it. We say, okay, everything after the plus or minus is the what. Just reinforcing our knowledge is the margin of error. And the margin of error is made up of two components. It's made up of your confidence level right here and also the standard error of p hat, which is basically a measure of uncertainty in the estimate of p hat. So we have the confidence level by the z-score. The star means you get to pick it based on percent confidence. And then also sometimes called the critical value for the z-score. And then we have here the standard error. The p hat is the estimate, which is at the center of our interval. It's our best guess to say, it's probably around 32.8% mislabeled. It's probably about how much is mislabeled. But now we need to come up with the margin of error for the estimate. And the margin of error, we need to calculate by doing p hat. Let's do it perfectly. Here's p hat. Oops. 1 minus. There's q hat times p hat over n square root. That is the standard error right there, times 1.96. That is the margin of error. So are they wanting this as percentages? It is percent. So we need to times that by 100. So now I'm going to times this by 100, 2.64. That was just times 100 by it. And then we times the other one by 132.8. And these are all percentages now. And then we do the plus or minus on it. So 32.8 plus or minus 2.64. We'll surround it right here. So 32.8 plus this, 35.44. And that's the upper of the interval. And then the lower is going to be subtracting on it. So 32.8 minus that and 30.16. There we go. Let's go back over to the question. And to one decimal. Okay. So 30.2. And the upper on the interval was 35.4. So now, what does the confidence interval mean? Now, what do I suggest you do for the test? What do I suggest you do? If you're watching this right now, I want you to do this for the test. Don't even look at those answers. Don't look at those answers, because what are you going to have to do on the test? So if you are watching this and you're worried about your exam 3 grade, I'm telling you right now that on exam 3, there are written interpretations of confidence intervals and tests. So don't even look at these answers. Don't look at them. What do you want to be able to do? What do you want to be able to do? For these right here, you want to be able to what? So if you're preparing for the test and you want to make sure you have it down, I know it's like if you hear me say it, it's one thing, but it's like watching me play piano. If you watch me play piano, so we could maybe play some piano later, who knows what, but you're not going to learn as much as you sitting down and doing it. So just reading these answers or just hearing me say them is not going to do you as much help as just sitting down right now. And I want you to try to write this out with me. Try writing it down on your computer. Try writing it down on a sheet of paper. Try saying it out loud. That's going to create more mental memory for when you prepare for the test. Your interpretations are as follows. I am blank % confident that the true blank is contained in the interval blank to blank. This is how you interpret confidence intervals every time. There's other ways to do it. My Pearson's going to mix it up on you a little bit, but this is how I do it, and then I find the one that looks like it, and that's usually going to be the right answer. So what is this right? Yes, one. You can say one is. You can say one is. That works. Great job, Blake, right there. Got 3 points for that. That the true blank, and that's the hard part. A lot of people have a tough time with that second part. What were we trying to estimate, Blake? So it's easy to do the I am, or one can be 95% confident that the true what? What were we trying to estimate in this problem? So this is where usually the mistakes happen. What were we trying to estimate? Look up here at the question. What were we trying to estimate? We were trying to figure out the true what? Proportion of what? You're right. We're trying to estimate the true proportion of what? And that's because we did the interval with p hat and all that stuff, right? So if we're using p hat, we're trying to find p. So because p hat's the sample proportion, we want to understand the true proportion of what? Just think context of the question. So I am 95% confident the true proportion of what? I am 95% confident the true proportion of what? 95% confident the true proportion of what? Of mislabeled seafood packages. Yeah, right? Does that make sense? I'm 95% confident that the true proportion of mislabeled seafood packages is contained in the interval 30.2 to 35.4. We are 95% confident that the interval captures the true proportion of all seafood sold in the country that is mislabeled right there. So in 95% of samples, no, there is 95% confident the true proportion. Ooh. So we got to be careful. This one, there is 90. No, this is talking about a chance. It's not that there's a chance. It's good to see you, Timothy. This one's a little bit weird. See, they use the we are, which is similar to I am, 95% confident. So this is going to be the most similar right here. 95% chance talks about like almost like one interval has a chance, but intervals containing the truth is a process of repeatedly making intervals. It's not about one interval. It's about the repeated process of intervals. Is the government spokesman valid in their criticism? A government spokesman claimed the sample size was too small relative to the billions. No. It's you. As long as your sample is representative of the population, then increasing the sample size will just decrease the standard deviation. A lot of people say that, like, oh, there's tons of seafood in the United States. How could you possibly understand it with 1,215 samples? Well, if we representatively take our samples, then we can estimate what the truth is. So as long, let's see here. No, until another, no. As long as the necessary assumptions are met and conditions are met, the results can be generalized. Yes. So are they valid? That should be, oh, and do we have another one? Oh, did I not click? I didn't click this one. There, right there. Yay! Yeah. So as long as you meet the conditions, you can generalize your results. Good, really good question right here. But yeah, so as long as the conditions are met, then we have properly estimated what the truth might be. Very, very good question. Good questions today. All good questions. A city's ballot includes. Little chill music. Good to see you, Timothy. City's ballot. Look at here. We got some confidence intervals. So what do you think it's going to start out? What are we going to do to start, Blake? What are we going to be doing in seconds from now? You know what we're going to be doing. We're going to be doing that notation, brother. Here we go. Let's go ahead and grab the question. Go over here, drop it in, and start some notation. Know your notation. Okay, so I think they did 2 samples right here. So let's take a look at these 2 samples. Okay, the local newspaper finds this. And a college statistics class finds this. The values in yellow are what? The values in yellow, then we'll call this N sub 2. That just means of the first group of the second group. So that's just of each group right there. And then what will we call the other ones? Just the subscript of 1 and 2 just means sample size 1, sample size 2. So just sample size N sub 1 of group 1. Yellow is P hat. Hey, Fatima, good to see you here. There we go. Good morning, Taylor. Great to see you here. I think, did you email? One of the Taylors emailed me the question. If so, we've already done one of the questions. Which person said? Someone emailed me. Yeah. Oh no, I think it was the other one maybe. But I already did. Good to see you here, Taylor. We're working on this one right here, doing the notation. And now we just solve. So let's see how am I going to decide what Z to use? How am I going to decide, is it P hat because it is the percent from the, yes, exactly. It's P hat because it's the percent from the, I know, where is Evan? It's P hat because it's the percent from the sample, the proportion. Also proportion, but you can think of it as percent. You can just turn it back to a proportion right there. How am I going to decide that Z, which it might use the same for both? It's saying down here, where does it say? Where's it say? Oh, there it is. So it says both groups will create 99% confidence intervals. How will I decide that 99% well, I'm alluding to it. There it is right there, 99% confidence. What's the z-score for a 99% confidence interval? What is the z-score for a 99%? There we go. Wow, nice job, Timothy. Excellent work, Timothy. Let's throw you some points. So go ahead and look it up right here while I'm typing this out. We can do that one next. You got it, Taylor. So the z-score for a 99% confidence interval, we need to go to the applet right here, and we click the second button, and we type 99 in, and then we go to the between, and we give you these types of answers on the test to say the z-score for a 99% confidence interval is 2.576. And look how it contains the middle 99%. That's what confidence intervals do, is shade the middle area. So what are the words you look for to determine your T or Z? The T or Z, and make sure it has a star. That's for confidence intervals. So that's when we do confidence intervals, it has the star, and that is based on the percent confidence. So as I highlight right here, this is the key thing to look at, is when it says like you're this confidence. So you see how it says like 99%. You're gonna, there we go. 99% confidence interval. So it's based on the percent confident. Good questions, Blake, right there. Does that make sense to say when you talk about how confident you are, that's going to be relative to your T or Z for the confidence interval? Be careful. It won't be the same thing as a test. The test Z does not have a star in it because you solve for that. I'll write it here very briefly. But when we do the one sample Z test, it's Z equals P hat minus P naught over P naught Q naught over N square root. And that is the one sample Z test. I'm just going to erase it. But that Z does not have a star on it. The star means you pick it based on confidence. So always be looking for this star right here, which means relative to a confidence level right there. When we talk about how confident we are, we use the Z star. And T star is also relative to a percent confident. So when you see the star, that means you're doing percent relative to percent confident, and it means it's for an interval. If you're seeing the other one, like this T right here, T equals Y bar minus mu naught over S over square root of N. That is a one sample T test where you solve for T. It does not have the star, which means you're not picking it on percent confident because this is a T test, not a T interval. We'll be reviewing that a lot. It's just a common misnomer where people say, well, what T do I use? And I say, well, that one solves for T, where this one is using a certain Z. Wait, so how do you determine which one to use? If we say, oh, so the T is used for quantitative. Mr. T is mean. You'll hear me say that a lot. So is this a quantitative or categorical question? We're asking, are people going to vote for this issue? Good to see you, Evan. So the T is quantitative. The Z is categorical. Is this quantitative or categorical? We're asking, are people going to vote for it? Like the dynamic duo is here. So if we're asking if people are going to vote for it, this is a categorical question, categorical, which means we're using Z. And so also the formulas dictate it too. So look through your notation. Good job, Timothy, right there. What does the class and the office hours schedule look like next week? Every day we're here Monday, Tuesday, and then Wednesday, Thursday, Friday off. Woohoo! Holidays. So disappeal. So for T is quantitative and Z for yep, exactly. T's are quantitative, Z's are categorical. And sample size, the 55 one. Oh no, we don't have class on Wednesday. We have class canceled on Wednesday. Do you know what day? Friday. Thank you, Sarah, for asking. Friday is when it looks like Terry was sending out announcements. I'll be talking about that in class. Friday is it looks like when it's gonna be sent out. I'm excited, and that I think it gives about 2 weeks. Terry was saying we were talking about that last night. So what quantity have I just calculated right here? I'm putting it over what I calculated. What quantity did I just calculate? You're welcome, Sarah. What quantity did I just calculate? I just did 0.54 times 0.46 times over 1,550 square root. I just calculated the what value. Not quite the margin of error yet. This is the standard error. Oh, wow. Oh, my gosh. This is the standard error. So this is the standard error. technically the standard error, kind of standard deviation. It's kind of standard deviation, but that is this quantity right here is the standard error of p hat. This is the critical value. This is plus or minus the estimate. And everything over here is the margin of error. So this is the standard error right there if we calculate just that value. Timesing it by the z-score, which is the critical value, turns it into the margin of error. So it's, how many decimals do we need on this? Let me see the decimals. Okay, it's going to be percent to 1. I think we'll be all right. So 3.26. Let's leave it at that. Okay, so the first interval, 3.26. 54 plus or minus. And the second interval will have a wider margin of error because it has a smaller sample size. So 0.55 times 0.45 divided by 400. Yeah, it's a wide interval because of that. I was thinking it over and I was like, is that right? So it should be smaller. I mean, wider because smaller sample size. There we go. Wow, 6%. I want to double check my math. That's really large. 6.4. Okay, good. So the top interval, and we can probably round that to 3. It does have, I've looked at the, okay, there we go, let's round that. And now we do 50. How did I get 50.7 right there? How am I getting 50.7? Who can show the math to get 50.7 in the chat? I'm doing a little bit of math in my head right here and taking these numbers and solving over here on this side. That's a 50.7 right there. And then this one down here is 48.6. And then 61.4. There. Should be right. Seems very wide. Let me look at the math again. Yep, great job, Timothy, right there. So 54 plus 3.3, there's that. 54 minus 3.3, there's that. And so the other one, 55 plus or minus that. 0.55 times 0.45 divided by 400 square root times 2. I guess it is. Let me go look at R real quick. Prop test. And then, so we would need out of 400 times, was it that? That is the X. 400 has that. And then the N was 400. And so this is saying about 50 to 60%. I guess. Huh. And then that's 1550. $51.5 to 50. Getting tighter intervals. Oh, I know why. I know why. Because this does 95% confidence intervals by default. And it wants 99. So there we go. 50.7 to 57.3. So same answer there. And then change this to 0.55. Change this to 400. This uses chi-squared, so it's sometimes a little bit different. 48.4 to 48.4 basically, and 61.4 right there. Yeah. Good to see you here, Allie. So for decision trees, is the R squared presented in decimal form or in percentage? It's presented in decimal. These are the answers right here. Follow through the steps. Lot of calculations to do this one. Okay. So the first question asks, without finding the confidence intervals, explain which one will have the larger margin of error. Okay. So if the sample size increases, the margin of error gets wider. If the sample size increases, and you can see it right here, the margin of error gets wider. If the sample size increases, the margin of error gets wider. If the sample size is larger, the margin of error gets wider. You can see it mathematically here. If the sample size increases, so wait, let's look at the formula again. You ready? If the sample size increases, so p hat plus or minus z star p hat q hat over n square root. So because it's over n, we are dividing by. Does that make sense? Good to see everyone here. So this is a good note to have. We've definitely asked test questions like this, that if you increase sample size, margin of error gets wider. No, don't worry. And great job, Ali, right there. 1,000 points for everyone being here. If you increase sample size, margin of error will get wider. If you increase sample size, margin of error gets smaller. Good to see you here, Caden. You can also see it here from our answers. Looking over the answers that we just solved for, here is the one with the larger margin of error. I mean, the larger sample size and smaller margin of error. The margin of error was this. And then here is the one with the larger margin of error and the smaller sample size. So when margin of error, real talk, will it be in decision trees on the final? There could be conceptual like tools and techniques questions, but no actual solving a decision tree. There could just be something like, would you use a decision tree here? Good question right there, Sarah. So without finding the confidence intervals, which will have the larger margin of error, which one is the smaller? So the statistics class will have the larger margin of error, at least mainly because, oh my gosh, it has a much smaller sample size. So that is another concept which we don't really get into, and I'm glad they're not doing that, but that is also theoretically possible too. So it has a much smaller sample size. That is easy to look at right here, and one of the things I noticed. So now we need to put in both those answers. I'm going to put up the screen right here real quick. Let me get those answers to the questions on the screen at the same time. Check out where we were just solving these questions out. And so make sure to solve this out right here for all these answers. Hopefully we've carried all of our decimals. The local newspaper is the bigger one, which has the smaller right there. If you put a number in the wrong way, this problem comes out wrong. So this one, even I'm a little bit worried about that we did it step by step. Wait, this is the local newspaper is the bigger sample. The local newspaper is the bigger sample. If you reverse things, let me know. If you just reverse it like this, like I was about to do, just tell me. The local newspaper is the bigger one. Statistics class 55. Okay, that is correct. So the local newspaper is this one. Okay. I'm so afraid I'm going to get this wrong. Good. That's right. And the statistics class is this one right here. Check out where we were solving this earlier. Yeah, I had it right. Does it always go correct? If you have a larger sample size, the confidence interval gets smaller. That is correct. Everything else remaining the same. All other things equal, larger sample size, smaller interval. Good questions. Okay. Whew. Okay, good. Thank you so much, Timothy, right there, confirming I had it right. It's your eyes look the wrong way, and then you get it wrong. Which group concludes the outcome is too close to call? Okay, so if we're looking at an election right here, which of these groups, the local newspaper or the college cost would be like, we don't know who's going to win, because we would say a candidate needs like 50% to win. So which of these would conclude it's too close to call? Which of these would be like, I don't really know? Which of these would we conclude? I'm still a little confused about that. Yes, that is correct right there, Evan. That is correct. I can go into greater detail on that in a second if you want. So the one that would conclude it's too close to call would be the statistics class, because 50% is included in the interval. You need 50% to win. The statistics class would say it's too close to call because 50% is in the interval. Does that make sense, Caden? To be like, yeah, we don't know who's going to win. Maybe they don't get 50% to win. Where the local newspaper would be saying, yeah, they're probably going to get more than 50%, somewhere between 50.7 to 57.3. The local newspaper would say, we are 99% confident that the true proportion of people who will vote for this candidate is contained in the interval 50.7 to 57.3. Yeah, message me. We'll talk about it. So the statistics class concludes that the outcome is too close to call since the interval obtained by these groups includes, my gosh, I mean, it's so much easier to write it out. What? This is the weird. Wow, this is just the weirdest thing. Okay. The statistics class concludes that the outcome is too close to call since the intervals obtained by these groups do not contain 50%. They should contain it. Contains. There we go. Contains. I was like saying because it's too close to call, it contains 50%. I was like, where's contains 50%? Just the weirdest way. No, not going to ban it. Should be right. There we go. Not going to ban it. It's just easier when you say it. It's just easier to talk about it than to like look at their questions or look at the way they word it. It's just like, well, if 50% is in the interval, ban the chapter. If 50% is in the interval, then 50% is a believable value. And since it's a believable value, well, it's like maybe they'll not get 50%. Maybe they'll get less than 50% because there's possibilities from the statistics class estimate that they'll get less than 50%. Mine is 48%. Here, we'll do it here. T statistic of this. So here we go, Taylor. Check this out. You ready? Your answers should be something like this. I'm going to plug it in. These are not going to be your exact answers, but if you're getting close to this, then you've probably done it correctly. If you get close to this, you ready? So for the 2,200, here we go for this one. Here's what you should be getting close to. Now, these are not the exact answers, but if your answers are kind of similar for that larger one with the larger sample, with 45.2 to 50.8. Now, don't put in these exact answers, but if your answers are close to those, it's 90% confident. So if it's 90% confident, you want to use a z-score, and these will be z-scores of 1.645. Is it 90% confident? Does it say 90%? 90% confident will be a z-score of 1.645, and we'll show that right here on the screen. So you want to go here and use a z-score of 1.645, and this will be a z-score for it, not a t. It'll be a z-score. So we need to go and always look up our t or z based on percent confidence level. So whenever it says this percent confident, your z-score will be 1.645, and this is the z-score, not the t, because the t is for quantitative. So this will be the z-score of 1.645. Now, these answers I'm about to show you are not the exact answers. They're close to it. For the larger sample size, you should be getting something about 46.2 to 49.8. Those are not the exact answers. And this is not a t for this one. This is the z interval. This is a 1 proportion z interval. And so for the smaller sample size, of 300, remember these are not exact answers because this uses the chi-squared distribution, which is a tiny bit different. They're good estimates. The z for both, correct, because they're both z intervals. And the second one uses 47%. And you should be getting for the second one something close to 42.1 to 51.9. Remember, these are not exact answers, but the second interval is going to contain 50%, the way this is looking. So these are not exact answers. Don't put them directly in, but this is the larger of the two interval estimate, and this is the smaller of the two interval estimate. You should be getting answers close to those when you do your math. If your answers are very different, then something happened wrong in the calculations. And so the bigger part of this question is doing the calculations right here. And so I've marked my notation, which I'll be finding the z in the correct. You should find the z in the David M. Lane. And when you go over here to the David M. Lane, you click the second button right here, 90%, and click the between. Does that make sense? So you have to go over here, and if it says 99, you put in 99. If it says 90, you put in 90. And that's where we solve right here for the z-score. And this would be given to you on a test. Does that make sense? We got time for about one more or so. These are really good in-depth question. Oh man, I love ham. Ham. Ham is some good stuff. Some honey-baked ham. I might order one. Piano time? Oh, we don't have time. Ham is amazing, man. Honey-baked ham, you get some like mustard and some maple glaze or something. Woo! Good stuff. I thought we have another one, other Taylor, both Taylors. Give another question right here. Where is Taylor? Other Taylor's question. Good to see you both. A poll conducted, chapter 13 homework. We could do the quiz version of it. Statute 1, chapter 13, quiz. A poll conducted. Let's go check that one out. So many questions. It's really good. The practice right here makes perfect or makes better. My mom and I had to start making homemade egg rolls. Oh my gosh. Bacon? Oh my gosh. Homemade egg rolls sound amazing. That is or spring rolls. Have you ever go to Taste of Thai and get spring rolls? Taste of Thai. Shout outs to them in Knoxville. Jerk chicken. That sounds really good. Some spicy chicken. Taste of Thai. Amazing. Let's get some pad ki mao or some tom yum goong. Tom yum goong is going to be tom kai gai. That's the coconut one. Tom yum goong is the spicy soup with shrimp. Tom kai gai is the coconut with chicken. So it's really good. Get tom kai gai. Oh man, I miss it. Let's do this question right here. Let's take a note on the time as we talk about some food right here. Charcuterie board. Wait, I thought I said charcuterie. Talking about some charcuterie board. Here we go. Let's do this question. It is time for a question. Okay, so what do we always do before we even look at what they're asking us? Before we even look at these? Oh, that sounds good. What do we even do? You know what we do before we even look at these. What do we do? Ooh, that sounds good, Evan, right there. Maybe I should do that for my wife. Make a charcuterie board. What do we do? You know what we do. We're about to do it right here. Don't even look at their questions.
Notation, brother.
Always write down your notation. Always write down your notation because it's going to direct you on what to do. So don't even look at their questions yet. The notation's going to help you out. Know your notation. I'll highlight it. You help me out. So I'm highlighting the notation. That's all we have. Help me out right here. What do we have notation-wise? There's 3 things right now total that you should have. So what should you have? Because one of them will solve for. Ooh, fries, watermelon. What? Basically, so Evan, close. Not quite, because this is going to be from a poll. Very close. And we have N for sample size. Good job right there. That's N. And so not quite P. And Ali is right. That's P hat. And P hat is usually given as a what? And then great job, Ali, right there. Shout outs. Let's throw some big points right there. They're usually given as decimals. We want to give them as decimals because we'll use them that way in equations. So we have found Q hat also, which is 1 minus P hat. And then try remembering how to say this is the percent of the sample that answered the question in the affirmative. So it's the percent of successes in a sample or proportion. I think that's right. 1 minus P hat is Q hat. So we found this right here. We'll be using it in the formula P hat plus or minus Z star. How will we figure out what Z star is? We don't have enough information currently to figure out Z star. How are we going to go figure out Z star? And great job right there, Evan. And then, but make sure to do as a decimal though, Evan. Make sure to express P hat as a decimal because when we do proportions in the equation, they'll be used as decimals. So if it says 51.9%, turn it into a decimal to do kind of proportion out of 1. And then so we don't have enough information for the Z star yet. We don't have enough information for the Z star. How are we going to go and find Z star here? Z star, we do not have enough information for right now. We do not know this. How are we going to go and eventually get enough information for that? Oh, no worries, no worries. Yeah, you can kind of do that, but make sure then do it as percentages. The Z star will be based on the percent confidence. But now when we look at this, it's going to ask us about conditions, which have to be met. Condition 1 is random. We randomly select these individuals that we poll. Condition 2 is less than 10%, and then, which means we sample less than 10% of the population. Condition 3, we pause and we ask, what kind of data is this? And so great job right there. Success, failure, because it's categorical. So when we look at the conditions right here, they kind of mention it. They're all passed. There are at least 10 successes in the sample. There are at least 10 failures. They go through all of them right here. So those are the conditions. Really long-winded way of doing it. The margin of error for the portion of all Californians considered a moving state is this. Would the margin of error be larger or smaller for 99% confident? So what happens to the Z-score if you go from 90 to 99%? Yep, it'll be the nearly normal condition for that. Tevin's question. If you go from 90 to 99%, what happens to the not quite law of large numbers? That's the large enough. You're thinking of large enough N, Alley. And to Rosemary, more often than larger. Correct. I think Rosemary right there. So I'm answering like 3 questions at one time. I hope everyone got all the answers. Large enough N, exactly. And so to Rosemary's answer right there, perfect. And Rosemary, if you have another question, we can probably do it. The Z-score gets larger when you go from 90 to 99. The Z-score gets larger, so the margin of error is going to get wider. the z-score from 90 to 99 gets larger, so the margin of error of this interval is also going to get wider. If you go from 90 to 99, the z-score gets larger, and the margin of error is everything over here. So if you go, it's larger, exactly. So if we have a more confident interval, it contained the truth more often. So to be more confident, the interval needs to contain the true proportion more often. I think that's got it. So the margin of error would be larger, and that, I think that's what Rosemary was answering right there. Yay! Actually, I knew someone growing up. I knew some Poplins growing up. So if you know some Poplins from Winston-Salem, so I don't know if like, it's a family over there, but it's interesting. I see that name and I'm like, I remember some people. I had some people I knew growing up. Back in the day, back in the 90s, good old 90s. So what other questions do we have? We have like 7 more minutes. We're going to have a special guest at the start of class today. What other questions? Should we do one more? What should we do? We've got time. We've done a good bit of questions. We did 4. These are tougher questions. Still time you've been doing these questions I'm working on. I didn't realize because I was just vibing. Vibing came about like 2 years ago. We watched Bachelor in Paradise. I'm trying to think who's everyone's second favorite couple in Bachelor in Paradise? Because you asked favorite couple. What's this? Is it Brandon and what's their name? Consumer Advocacy. What's Brandon's girlfriend's name? Totally. And then I'm stuck on night. Red Snapper. Yeah, we'll do Red Snapper. Let's do Red Snapper real quick right here. And then we'll try to do both. Let's try to do both. We're going to do them quickly because we got little time. Never seen a Bachelor show? You're missing out. Best, worst TV there is. I got here a bit late. Is that bad? It's whatever you want. It's preference. You can, it's whatever people want. And we've done all the homework questions in the Monday video, I think. So if you're looking for one of the homework questions, they are in the Monday video. Remember, everything is notated afterwards. We're going to try to do both questions pretty quickly right here. So if you're looking for a slower way of doing it, I've heard of Peaky Blinders. Is that show with, I can't remember who it is. The guy who played Scarecrow. What's his name? He's a really good actor. Cillian Murphy, right? Cillian Murphy, that's his name. Oh, there it is. There's the consumer advocacy. Yeah, Cillian Murphy, I think is his name. Really good actor right there. Okay, so with this one, a consumer advocacy group published a study about seafood sold in 3 states. Let me take the note on this. I think this is the one Rosemary was asking about. We're going to try to do it. So here we are. We're going to take the note on this, and we're going to try this really quickly. So if we go too quick on this question for people, please check out Monday's video where we do this much more slowly. We're just going to solve this one quickly. So this is kind of the pro version of this question, but check out Monday's video where we do it much more slowly. Are the conditions met for meeting this? We need at least 10 successes, at least 10 failures. And we do have at least 10 successes, at least 10 failures in the sample. There are 13 failures. Yes, because it's a random sample, it's less than 10%. And there's at least 10 successes, at least 10 failures. Yes, because sample size is simple random. The sample report, no. So there we go, 10 successes, 10 failures. 95% confidence. Zoe, good to see you here. We're doing this one quickly, so please check out Monday if you want to go more slowly. 95% confident. What z-score do you hear in your head immediately when you hear 95% confident? 95% confident, the z-score that we use, go to the David M. Lane. 95% confident, the z-score you should be thinking of is what? 1.96, and we will give those to you on the test. We had right here for the question that n was equal to 28. Please don't get it wrong. X is equal to 15. That means we can find p hat. P hat is x over n. Q hat is going to be 1 minus p hat. And so x over n is going to be 15 over 28. There it is right there. So that is p hat is equal to 0.535. Q hat is about equal to 0.465. We're going to do p hat plus or minus z star square root p hat q hat over n. Please check out Monday's video. I'm going to go way more slowly. 1.96 though, not 1.965 though. 1.96. 1.96. I just want to double check everyone's knowledge right there and work on it. 1.96, no 5 afterwards. Technically, it's 1.95996, but Don't do that. Remember, 1.96. People are gonna yell at you in statistics if you put extra decimals. I just like being. Brian is always extra. It's gonna be a very wide margin of error on this because of small sample size. 1 minus that times this, divide by 28, square root. That's the standard error. The margin of error is ridiculous. 18.47. 18.47. 18.47. So it wants as a decimal. 18.47. And 15 out of 28. 72. Wow. 0. It's Brendan and Serene, right? That's their names. They are the best couple, I think. 35.1. I'm gonna cheat. Prop test. And it was 15,28. 34.72. About. Okay, good. Is that what you're... I give it a 34%? Question whether Brian sees it. Standard... Oh, okay. Did people already calculate the standard error with me too? Oh my gosh. Thank you, Evan. Yeah, sure. Let's give you 10,000 points. Thank you, Evan. I really appreciate you doing the work along with me. I am 95% confident that between blank to blank, and that's the true proportion, then we need to times it. Thank you for doing the work along with me to make sure I get it right. That should be right. Woo! Good work. I am 95% confident that the true proportion of mislabeled seafood is contained in the interval blank to blank. Do we have enough time to do the other one? What was the other one people wanted really quick? I'm just worried about getting it wrong. If you do it in R, you can just be like, I am 95% confident the true proportion of mislabeled seafood is contained in the interval 34.2 to 71.9. And you can just get it right here. Like we could take this right here, store it into X, take here the, where's my interval? The estimate, the confident right there. Take the confident right there. Take the first thing out of the confident list. No, that's the lower value. Sure. Let's take the lower value and take that. Take the upper value. And there's the values right there. Go here to round and round to, well, first let's times by 100. That's a horrible way of doing it. There's my alarm to go meet with the person. And times 2. And there you go. I think I got to go. We have a special guest coming to class a little bit early, so we might start class a little bit early. Email reminder. Oh, we got to send the email reminder. Oh my gosh. So there it is right there, the quicker way of solving it with code. And we can just run the code right here to find the answer. Code will show you answers all the time. Special guest to talk about some study abroad. With that, we'll do more. Is it Jolly? I wish it was Jolly. Oh, Jolly's great. With that, I'll see everyone next in class here in 10 minutes. Bye!